How's everything going? This video we're going to look at the derivatives of the other trigonometric functions. The video before this one was finding the derivative of sine and cosine. This is the other ones: tangent, tangent, cotangent, secant, and cosecant. So let's go ahead and get started. So if you watched the last video, as I said in the last video, in order to find these derivatives, you've got to memorize these. This is tangent, cotangent, secant, and cosecant. You've got to know them. Remember, derivative of sine is cosine, derivative of cosine is negative sine. That was the last video. Well, now you got to memorize these. So derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. And the thing you got to remember, you got to remember these things, but also remember each one of them, it's times the derivative of whatever you're taking the tangent or cotangent or secant or cosecant of. So in other words, derivative of tangent is secant squared u times the derivative of what you're taking the tangent of. And that's the same for each one of them. You got to multiply by the derivative of whatever that angle is. All right, so let's go ahead and get started with some examples. All right, so here we go. Find the derivative. All right, so we've got y prime is equal to 2. Now, what's the derivative of tangent? Okay, what I would do is maybe pause the video right now, write all those down if you haven't already. And so you'll have them right there as we're working through the problems. Okay. So the derivative of tangent is what? Secant squared. All right. And then it's times the derivative of what you're taking the tangent of. So the derivative of 8x is 8. And so I get y prime is 16 secant squared 8x. And there's your derivative. All right. It's that simple. All right, so let's look at this one. I've got y equals 3 secant squared 4x. All right. Now, I did this in the last video, and I'm going to do it in this video also. Remember, secant squared, that's the same thing as secant in parentheses squared. That's what it means. We just don't write the parentheses raised to a power. We write it like this. We put the exponent right here. It's just easier to write. Okay? All right. So that means here we have to do the chain rule. Okay? We've got to do the chain rule. So we're going to get y prime. The 2 comes down. 2 times 3 is 6. And then what do? I subtract 1 from the exponent, so that would be to the first power. And then it's what? And then it's times the derivative of what's inside the parentheses. That's the chain rule. So now I've got to times the derivative of this. Okay, and before I do that, you see this secant 4x in parentheses to the first. That is just the same thing as secant 4x. Okay, you don't put the parentheses to the first power. Okay, but look, the 2 came down. That's 6. Subtract 1, so that's to the first power. Okay, and then it's times the derivative of what's inside the parentheses. So times the derivative of secant 4x. Well, what's the derivative of secant? That's secant tangent. And notice when I'm saying this, I'm not including the angle, but the angle is included. Okay, just remember, derivative of secant is secant tangent. And yes, you've got to write the angle with it. Okay, so the derivative of secant 4x is secant 4x tangent 4x times the derivative of what you're taking the secant of. So the derivative of 4x is 4. And then we're going to clean this up. So y prime is 24 secant squared 4x, just multiplying the secants together, times tangent 4x. Okay, and there's your answer. Look, don't make this difficult, because it's not. It's really not that difficult. All right, so how about this one? Y equals t times cosecant cubed of 2t. So the first thing I'm going to do, y equals t cosecant 2t, all of that cubed, right? Instead of, this cube right here, I'm just going to write it in parentheses, raised to the third power. And the only reason I'm doing that is because it helps you see the chain rule better. Okay? This step right here, you don't have to do this step. Just do this step if it helps you to see that it's in parentheses raised to a power. All right, so how do we take the derivative here? Well, this is product rule, isn't it? See, I've got my first function and my second function. So the product rule, y prime, that's the derivative of the first function, which is 1, times the second function. So times cosecant 2t cubed. Okay, so we're doing the product rule, derivative of the first, which is 1, times the second function, plus the derivative of the second function. Now, I'm taking the derivative of all of this right here. Cosecant 2t cubed. That's chain rule. So the 3 comes down, and then that's cosecant 2t squared, right? The 3 comes down, subtract 1. And then it's times what? Times the derivative of what's inside the parentheses. So what's the derivative of cosecant? Well, that's negative cosecant cotangent. Okay, that's the derivative of cosecant. And then it's times the derivative of what you're taking the cosecant of. So the derivative of 2t is 2. All right. Now, obviously, we need to clean this up some. So we've got y prime. That is cosecant cubed 2t. I'm going to go ahead and not write the parentheses anymore. And then that's going to be minus, what was that, minus 6. Oh, I'm sorry. Look what I did. Hang, let me back up. All right. I got caught up so much in explaining all this to you. Okay. So the product rule, derivative of the first function, which is 1, times the second function, which is this, plus the derivative of the second function, which is all of this right here. Okay, chain rule on this. And then what did I forget to do? Times the first function. I forgot to put times that first function. Oh well, but all right, everybody good now. Okay, so y prime. You see, when you start doing these, all this excitement builds up, and you forget to put stuff down. All right, so this is going to be cosecant cubed 2t minus, that's going to be, because see, I got the minus here, the 2, the 3, and the t, so minus 6t, and that's going to be cosecant cubed 2t. I'm also, what I'm doing is I'm distributing this, well, not really distributing, but just multiplying the cosecants together, basically. All right, and that's going to be cotangent 2t. All right, And then, yeah, we can simplify this a little more. We can factor out a cosecant cubed. Cosecant cubed 2t. And that'll leave us with 1 minus 6t times cotangent 2t. And there's your answer. All right. So, sorry about missing that, but, you get caught up in explaining all this stuff. You just forget to finish out a problem sometimes. All right. So hopefully that made sense. Hopefully that didn't screw you up too bad, me missing that. If it did, sorry about that. All right. I need to rewrite this problem. I left off a parenthesis. All right. So let's see about working this one. So I've got something in parentheses raised to a power. That's chain rule right there. And so I get y prime is 3 times tangent 2x plus secant 2x squared. All right. Now, chain rule. Exponent comes down. Subtract 1 from the exponent. Times what? Times the derivative of what's inside the parentheses. So now I got to take the derivative of this. So derivative of tangent is secant squared times the derivative of what you're taking the tangent of. That's derivative of tangent plus the derivative of secant 2x. What's the derivative of secant? Well, that's secant tangent times what? Times what you're taking the secant of. So the derivative of 2x is 2. All right. All right, so let's see if we can simplify this a little bit, clean it up some. So I've got y prime is equal to, that's going to be 6 secant 2x. Now, where did that come from? Well, I factored out a 2, and I factored out a secant 2x. Okay? That's where the 2 times 3 is 6, and then factored out a secant. That's where the secant 2x comes from. Times, and now what I'm going to do, I'm going to write this part down. That's tangent 2x plus secant 2x squared. Times, and now let's deal with this. So I factored a 2 out, and I factored out a secant 2x. So if I factor the 2 out, that 2's gone. Factor out a secant 2x, that's going to leave me with secant 2x plus, and then this secant 2x and this 2's gone, so that's going to leave me with tangent 2x. And so that's going to give me y prime is 6 secant 2x times, now, do you see here, let me change colors. Do you see here how we have like bases? This is to the first power. I know the tangent's written first here, secant's written first here, but you can swap them. These bases are the same. What happens when we have like bases and we're multiplying? That's going to be tangent 2x plus secant 2x. You multiply like bases, what do? Add the exponents. 2 plus 1 is 3. And there's your answer. All right. All right, moving right along. Find the differential. All right. So let's do this. We've got r equals sine 2 theta tangent theta squared. And we want to find the differential. So we've got dr is equal to, now when I find the differential of this, what do I have to do? Product rule. So the product rule, I've got 2 functions here. There's my first function. There's my second function. So the derivative of sine 2 theta is cosine 2 theta times the derivative of what you're taking the sine of, which is 2, times the second function. Okay? So this is the derivative of the first function, and then times the second function, plus the derivative of the second function. Well, what's the derivative of tangent? That's secant squared times the derivative of what you're taking the tangent of. So the derivative of theta squared is 2 theta. So that's the derivative of the second function, and then times the first function, sine 2 theta. And so, and so that's all times d theta. We're finding the differential. So dr is going to be, that's going to be 2 cosine 2 theta tangent squared, not tangent squared, tangent theta squared, plus, let's see, that's going to be, what was that, 2 theta secant squared theta squared sine 2 theta. And honestly, I don't think there's really not much you can do with this. I mean, I guess if we wanted to, and let's times d theta, forgot the d theta. I mean, if you wanted to, you could factor out a 2, but there's no need in that. So we'll just leave it. We'll leave it like that. All right, so there's your answer. All right. Let's look at this one. Find dy dx. This is implicit differentiation. See, we got a implicit function here. So let's write it down. We got cotangent 2x minus 3 cosecant xy equals y squared. And I know it tells us to find dy dx, but let's just say, okay, let's find y prime. It's the same thing. It means the derivative. It's just different notation of representing the derivative. That's all it is. All right. So implicit differentiation. Hopefully you still remember how to do this. So the derivative of cotangent is what? Negative cosecant squared 2x, right, times the derivative of what you're taking the cotangent of, so times 2, minus, now the derivative of this, so that's going to be what? Minus 3. Now what's the derivative of cosecant? The derivative of cosecant is negative cosecant cotangent, right? That's the derivative of cosecant times the derivative of what you're taking the cosecant of. So I got to take the derivative of x times y. That's product rule. So that's going to be what? Derivative of the first. Now remember, I'm going to write it here. I'm taking the derivative of x times y. Derivative of x is 1 times y, plus the derivative of the second function. Derivative of y is 1 times y prime. Remember? Times x. And then that equals 2y times y prime. All right. And now what do we have to do here? Well, we got a big old mess now, don't we? So I'm going to need to distribute this. So let's see what we get. We get negative 2 cosecant squared 2x. The negative and negative make a plus. So that's going to be plus 3y cosecant xy cotangent xy. What I'm doing here is the minus and minus make a plus. So I'm taking this and distributing it to that. And then that's going to be plus, let's see, how do we want to write this? 3x y prime cosecant xy cotangent xy equals 2y y prime. All right. Now, what do we do here? Well, now we got to solve for y prime. So everything that has a y prime has to come to one side. Everything that doesn't have a y prime goes to the other side. So I need to take this term right here and move it over here. So what is that gonna do? Well, that's gonna leave me with 2y y prime minus 3x y prime cosecant xy cotangent xy equals, I'm just writing the y primes on the left side, and that's going to equal negative 2 cosecant squared 2x plus 3y cosecant xy cotangent xy. And so then I'm going to factor out this common factor, y prime times 2y minus 3x cosecant xy cotangent xy equals negative 2 cosecant squared 2x plus 3y cosecant xy cotangent xy. All right. And so this is going to leave me with y prime is negative 2 cosecant squared 2x plus 3y cosecant xy cotangent xy over 2y minus 3x cosecant xy cotangent xy. And that is going to be your final answer. All right, so that problem there, that one was kind of nasty, but we still got it, so it's all good. All right, how about this one? And this is actually, this is the last problem. All right. All right, evaluate the derivative of this where x is equal to 0.25. All right, so let's write this down. Y equals 2x over 1 minus cotangent 3x. So let's find this derivative. So I've got y prime equals, here I've got to do quotient rule. So it's the derivative of the numerator times the denominator minus the derivative of the denominator. All right. So the derivative of the denominator, derivative of 1 is 0. And then I've got my minus here. And then derivative of cotangent is what? Negative cosecant squared 3x times the derivative of what you're taking the cotangent of, which is 3. And then times the numerator. So let's go over that one more time. This is the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. Okay? And this is all over the denominator squared. So let's just clean it up some. So I got y prime is 2 minus 2 cotangent 3x, and then minus and minus is a plus, so that's going to be what, 6x cosecant squared 3x over 1 minus cotangent 3x, all of that squared. So there's our derivative. All right, so what do they want us to do? They want us to evaluate this at 0.25. Okay. All right, so look, let's do this. So I'm plugging the 0.25 in for x, right? That's what I'm plugging the 0.25 in. And notice every one of them's 3 times. So 3 times 0.25 is equal to 0.75, right? And so this is going to be 2 minus 2 cotangent. 3 times 0.25 is 0.75. So I'm going to plug in the 0.75. Okay, this right here is the same thing as 3 times 0.25. I'm just not showing this step. Okay, and then that's going to be plus 6 times 0.25. That's just x, so that's going to be 0.25. And then cosecant squared 0.75. 3 times 0.25 is 0.75 over 1 minus cotangent. 3 times 0.25 is 0.75, and all of that squared. And when you punch all of that into your calculator, you actually get negative 626. Well, I don't know. There may be some decimals, but it's rounding it to a whole number. Okay. I didn't actually put it in my calculator. I got the answer in the book, so I just wrote it down. I don't want to put all that in my calculator. But just to help you out, if you're punching this into your calculator, this cotangent of 0.75, you would have to type in 1 over tangent 0.75. For this one, you would have to type in 1 over sine 0.75, and then you would have to square that thing. And then for this, you would have to type in 1 over tangent 0.75. Now, I'm not going to do it because I can't show you on here how to do the calculator, but y'all should know how to use a calculator by now. Okay, I have confidence in y'all. But yeah, that's the video. So the video before this one and this video, they kind of go together. Okay, if you're in a regular calculus class, then this is all one section. In applied calculus, they're splitting it up into 2 different sections. Okay, that's why I did 2 separate videos on it. But there it is. Watch them together. They kind of go together. So watch the one before this one and watch this one. Hopefully you've already watched the first one and now you're watching this one. But anyway, I'll shut up and end the video. But yeah, that's it. Hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.